The note about maintaining a minimum 24-inch separation where boxes are mounted on opposite sides of walls is a general note and not specifically tied to the National Electrical Code, the Florida Building Code, or the National Fire Protection Association standards. However, this 24-inch separation is commonly found in fire-rated wall construction. Looking at fire-rated walls, firstly, the National Electrical Code does not specify a minimum separation distance for boxes mounted on opposite sides of a fire-rated wall. Secondly, NFPA 70, which is the National Electrical Code, also does not specify a minimum separation distance for boxes mounted on opposite sides of a fire-rated wall. Thirdly, the Florida Building Code Section 720.18 requires a minimum separation of 24 inches between boxes mounted on opposite sides of a fire-rated wall. Now let's consider non-fire-rated walls. There is no specific requirement in the NEC, the NFPA, or the Florida Building Code for minimum separation distance for boxes mounted on opposite sides of a non-fire-rated wall. However, it's considered good practice to maintain a reasonable separation distance to avoid interference between the boxes and to allow for proper wire routing. In general, a separation distance of 24 inches is recommended for boxes mounted on opposite sides of both fire-rated and non-fire-rated walls. This distance provides ample clearance for wire routing and access to the boxes for maintenance or repairs. Therefore, while not always a strict code requirement, especially outside of the Florida Building Code for fire-rated walls, adhering to a 24-inch separation can be a beneficial standard practice. This practice aids in organization future modifications and reduces potential issues related to heat dissipation or electromagnetic interference, although those are not typically the main concerns for this spacing. When installing electrical boxes, especially in commercial or multi-family dwellings, always check the local building codes and any project-specific specifications, as they may have stricter requirements than the NEC or the NFPA standard. Always consult with the local authority having jurisdiction, or UDGE, to confirm the proper installation methods and required separation distances. Remember, fire-rated walls are designed to prevent the spread of fire and smoke, and maintaining the integrity of these walls is crucial for safety. Penetrations in fire-rated walls must be properly sealed with approved fire-stopping materials to maintain the wall's fire resistance rating. The 24-inch separation rule, where enforced, helps minimize the impact of electrical box penetrations on the wall's overall fire resistance. When installing boxes in non-fire-rated walls, the main considerations are typically ease of access, wire management, and avoiding interference with other building systems. While a 24-inch separation is a good guideline, it's not always necessary and can be adjusted based on the specific circumstances of the installation. Consider the following points when installing electrical boxes. Firstly, check local codes and project specifications. Always verify the specific requirements of the local building codes and any project specifications, as they may have additional requirements or restrictions. Secondly, consider the wall type. Determine whether the wall is fire-rated or non-fire-rated, as this will affect the separation requirements. Thirdly, plan your layout. Plan the layout of the electrical boxes carefully, taking into account the location of other building systems and the need for access and wire management. Fourthly, use appropriate fire-stopping materials. When installing boxes in fire-rated walls, use approved fire-stopping materials to seal any penetrations and maintain the wall's fire resistance rating. Fifthly, maintain reasonable separation. Even in non-fire-rated walls, maintain a reasonable separation distance between boxes to avoid interference and allow for proper wire routing. Sixthly, consult with the authority having jurisdiction. If you have any questions or concerns, consult with the local authority having jurisdiction for clarification. Additional factors to consider include, firstly, the size and type of electrical boxes. Larger boxes or boxes containing heat-generating devices may require more separation. Secondly, the type of wiring method. Different wiring methods may have different spacing requirements. Thirdly, the presence of other building systems. Avoid placing boxes in areas where they may interfere with other building systems, such as plumbing or HVAC. Fourthly, accessibility. Ensure that the boxes are easily accessible for maintenance and repairs. Fifthly, future modifications. Consider the possibility of future modifications and ensure that the box layout allows for flexibility. Let's talk more about fire-rated walls. Fire-rated walls are designed to resist the spread of fire for a specified period, typically measured in hours. These walls are constructed of fire-resistant materials and are designed to contain a fire within a specific area, giving occupants time to evacuate and firefighters time to respond. Electrical boxes and other penetrations can compromise the fire resistance of a wall if they are not properly installed and sealed. The 24-inch separation requirement, wormforce, helps to minimize the impact of these penetrations on the wall's overall fire resistance. When installing electrical boxes in fire-rated walls, it's crucial to use approved fire-stopping materials to seal any gaps or openings around the boxes. These materials are designed to expand when exposed to heat, creating a fire-resistant barrier that prevents the spread of fire and smoke. The NEC provides guidance on the proper installation of electrical boxes and the use of fire-stopping materials in fire-rated walls. Section 314.20 covers the requirements for boxes in fire-resistant rated walls, floors, and ceilings. This section requires that boxes be securely mounted and that any openings around the boxes be sealed with approved fire-stopping materials. The Florida Building Code also provides specific requirements for fire-rated walls and the installation of electrical boxes. Section 720.18, as previously mentioned, requires a minimum separation of 24 inches between boxes mounted on opposite sides of a fire-rated wall. This section also specifies the types of fire-stopping materials that are approved for use in fire-rated walls. When selecting fire-stopping materials, it's important to choose products that are specifically listed and labeled for use in fire-rated walls. These products have been tested and certified to meet the required fire resistance ratings. Common types of fire-stopping materials include fire-rated caulk, fire-rated putty, and fire-rated sleeves. Fire-rated caulk is a sealant that is used to fill small gaps and openings around electrical boxes and other penetrations. Fire-rated putty is a moldable material that is used to seal larger openings. Fire-rated sleeves are used to protect cables and wires that pass through fire-rated walls. When installing electrical boxes in non-fire-rated walls, the main considerations are typically ease of access, wire management, and avoiding interference with other building systems. While a 24-inch separation is a good guideline, it's not always necessary and can be adjusted based on the specific circumstances of the installation. In non-fire-rated walls, the NEC requires that electrical boxes be securely mounted and that any openings around the boxes be sealed to prevent the entry of dust and moisture. Section 314.17 covers the requirements for box fill, which specifies the maximum number of conductors that can be installed in an electrical box. It's important to ensure that the box is not overfilled, as this can create a fire hazard. Section 314.16 covers the requirements for box mounting, which specifies the methods that can be used to securely mount electrical boxes to walls and ceilings. When installing electrical boxes, it's important to use the correct type of fasteners and to ensure that the boxes are properly supported. In addition to the NEC and the Florida Building Code, other codes and standards may also apply to the installation of electrical boxes. These include the International Building Code, the International Residential Code, and various industry standards. It's important to be familiar with all of the applicable codes and standards before beginning any electrical work. When in doubt, always consult with a qualified electrician or electrical inspector. They can provide guidance on the proper installation methods and ensure that the work meets all of the applicable codes and standards. Maintaining the integrity of walls, whether fire-rated or not, is crucial for safety and the proper functioning of building systems. Following the guidelines and requirements outlined in the NEC, the Florida Building Code, and other applicable codes and standards will help to ensure that electrical boxes are installed safely and correctly. Let's further clarify the role of the NEC in electrical installations. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, as NFPA 70. While the NEC itself is not a law, it is often adopted by state and local jurisdictions, becoming a legal requirement for electrical work. The NEC provides comprehensive guidelines for electrical wiring, overcurrent protection, grounding, and equipment installation. It covers a wide range of electrical systems, including residential, commercial, and industrial applications. The NEC is updated every 3 years to reflect changes in technology and best practices. The latest edition of the NEC is typically adopted by state and local jurisdictions within a few years of its publication. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical installations, such as wiring methods, equipment, and special occupancies. Articles provide more detailed requirements for specific types of installations or equipment. Sections provide specific instructions for how to comply with the requirements of the NEC. The NEC is a complex and comprehensive document, and it's important to have a thorough understanding of its requirements before beginning any electrical work. The NEC is not intended to be a design manual, but it provides the minimum safety requirements for electrical installations. It's important to consider other factors, such as energy efficiency and convenience, when designing an electrical system. The NEC is a living document, and it's constantly being updated to reflect changes in technology and best practices. It's important to stay up to date on the latest edition of the NEC and to be aware of any local amendments or interpretations. Now let's delve into the Florida Building Code and its relationship to electrical installations. The Florida Building Code, or FBC, is a set of regulations that govern the construction and renovation of buildings in the state of Florida. The FBC is based on the International Building Code, or IC, but it includes additional requirements that are specific to Florida's climate and environment. The FBC covers a wide range of building systems, including structural, mechanical, plumbing, and electrical systems. The FBC is updated every 3 years to reflect changes in technology and best practices. The latest edition of the FBC is typically adopted by local jurisdictions within a few years of its publication. The FBC includes specific requirements for electrical installations, including the installation of electrical boxes, wiring, and equipment. The FBC also references the NEC, which provides more detailed guidance on electrical installations. The FBC is enforced by local building officials, who review building plans and inspect construction sites to ensure compliance with the code. The FBC is an important tool for ensuring the safety and welfare of building occupants. By following the requirements of the FBC, builders and contractors can help to ensure that buildings are constructed safely and efficiently. Let's consider the role of the authority having jurisdiction in electrical installations. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure. The AHA can be a local building official, a fire marshal, an insurance company, or another qualified entity. The AHA has the authority to interpret the requirements of a code or standard and to make decisions about whether an installation meets those requirements. The AHA is responsible for ensuring that electrical installations are safe and comply with all applicable codes and standards. The AHA typically reviews building plans and inspects construction sites to verify compliance. The AHA can also issue permits and licenses for electrical work. The AHA is an important resource for builders, contractors, and homeowners. If you have any questions or concerns about electrical installations, it's important to consult with the AHA for clarification. The AHA can provide guidance on the proper installation methods and ensure that the work meets all of the applicable codes and standards. Seeking guidance from a qualified electrician or electrical inspector is also beneficial. These professionals possess the knowledge and experience to ensure safe and compliant electrical work, offering peace of mind and mitigating potential risks. This is true if the electrical inspector is the AHA or not. The importance of proper wire management in electrical box installations should be discussed as well. Wire management refers to the organization and arrangement of wires and cables within an electrical box or enclosure. Proper wire management is essential for safety, reliability, and ease of maintenance. Poor wire management can lead to several problems, including firstly, overheating. Overcrowded or tangled wires can trap heat, which can lead to insulation breakdown and potential fire hazards. Secondly, shorts and ground faults. Damaged or improperly insulated wires can cause shorts and ground faults, which can trip circuit breakers and create shock hazards. Thirdly, difficulty in troubleshooting. Disorganized wires can make it difficult to troubleshoot electrical problems and can increase the time required for repairs. Fourthly, reduced airflow. Overcrowded wires can reduce airflow, which can lead to overheating of electrical components. Fifthly, difficulty in future modifications. Disorganized wires can make it difficult to add or modify electrical circuits in the future. To ensure proper wire management, follow these guidelines. Firstly, use appropriately sized boxes. Choose electrical boxes that are large enough to accommodate the number of wires and devices that will be installed. Secondly, avoid overcrowding. Do not overfill electrical boxes with wires. The NEC provides guidelines for box fill, which specifies the maximum number of conductors that can be installed in an electrical box. Thirdly, use wire connectors. Use appropriate wire connectors to join wires together securely. Do not use tape alone, as it can loosen over time and create a fire hazard. Fourthly, bundle and secure wires. Bundle wires together using cable ties or other suitable fasteners. This will help to keep the wires organized and prevent them from becoming tangled. Fifthly, label wires. Label wires clearly to identify their function. This will make it easier to troubleshoot electrical problems and to add or modify circuits in the future. Sixthly, maintain proper spacing. Maintain proper spacing between wires and devices to allow for airflow and to prevent overheating. Seventhly, avoid sharp bends. Avoid making sharp bends in wires, as this can damage the insulation. Eighthly, use strain relief. Use strain relief connectors to protect wires from being pulled or damaged. Proper wire management is an important part of any electrical installation. By following these guidelines, you can help to ensure that electrical systems are safe, reliable, and easy to maintain. In summary, when addressing the 24-inch separation for electrical boxes, remember these key points. Firstly, the NEC does not have a blanket requirement for 24-inch separation of electrical boxes on opposite sides of a wall, whether fire-rated or not. Secondly, the Florida Building Code Section 720.80 mandates a 24-inch separation for boxes on opposite sides of fire-rated walls. Always consult the local AHJ to confirm local code requirements. Thirdly, a 24-inch separation is the generally recommended practice for both fire-rated and non-fire-rated walls to aid in wire management, accessibility, and future modifications. Fourthly, fire-rated walls require special attention. Use approved fire-stopping materials to maintain the wall's fire resistance rating. Fifthly, wire management is crucial for safety and ease of maintenance. Follow best practices for organizing and securing wires within electrical boxes. Sixthly, always prioritize safety and compliance. When in doubt, consult with a qualified electrician or electrical inspector to ensure that electrical installations meet all applicable codes and standards. Consider the impact of box size and quantity on wall integrity, particularly in fire-rated assemblies. Larger boxes and numerous penetrations can weaken the wall's fire resistance rating. The selection of appropriate fire-stopping materials is critical to restoring the wall's original fire resistance. Ensure that the materials used are tested and listed for the specific type of wall construction and penetration. Proper installation of fire-stopping materials is essential to their effectiveness. Follow the manufacturer's instructions carefully and ensure that all gaps and voids are completely filled. Regular inspections of electrical installations are crucial to identify and address any potential problems before they become safety hazards. Look for signs of damage to wiring, loose connections, and improper use of extension cords or power strips. If you discover any problems, contact a qualified electrician to make the necessary repairs. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ensure that all electrical equipment and appliances are properly grounded. Use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the flow of current and will trip the circuit breaker if they detect a ground fault. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Ensure that the correct size overcurrent protection device is installed for each circuit. Do not replace a circuit breaker or fuse with a larger size, as this can create a fire hazard. It's important to understand the different types of wiring methods used in electrical installations. The most common types of wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, metal clad cable, or NEC cable, and conduit. NM cable is typically used in residential wiring, while NEC cable and conduit are often used in commercial and industrial applications. Each wiring method has its own advantages and disadvantages, and it's important to choose the appropriate wiring method for the specific application. It is important to understand voltage drop calculations and how they affect electrical installations. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or overheat. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are sized appropriately to minimize voltage drop. Let's discuss the use of electrical metallic tubing, or EMT, in electrical installations. EMT is a type of metal conduit that is commonly used to protect electrical wiring. EMT is lightweight, easy to install, and provides excellent protection against physical damage. EMT is typically used in commercial and industrial applications, but it can also be used in residential wiring. EMT is available in a variety of sizes and materials, including steel and aluminum. It's important to use the correct type of fittings and connectors when installing EMT to ensure a secure and watertight connection. Regarding flexible metal conduit, or FMC, FMC is a type of flexible metal conduit that is commonly used to protect electrical wiring in tight spaces or where flexibility is required. FMC is lightweight, easy to install, and provides good protection against physical damage. FMC is typically used to connect electrical equipment to a junction box or to run wiring through walls or ceilings. FMC is available in a variety of sizes and materials, including steel and aluminum. It's important to use the correct type of fittings and connectors when installing FMC to ensure a secure and watertight connection. Surface-mounted raceway is a wiring system that is installed on the surface of walls or ceilings. Surface-mounted raceway is typically used in commercial and industrial applications where it is not practical to run wiring inside walls or ceilings. Surface-mounted raceway is available in a variety of materials, including metal and plastic. It's important to choose a raceway system that is appropriate for the specific application and to follow the manufacturer's instructions carefully when installing the raceway. In conclusion, the 24-inch separation guideline is a nuanced issue. While not universally mandated by the NEC, it reflects a sound practice, especially in fire-rated constructions as per the Florida Building Code. A deep understanding of the NEC local codes and proper installation techniques is paramount for safe and compliant electrical work. When in doubt, consulting with qualified professionals ensures the integrity and safety of electrical systems. Always refer to the most current edition of the relevant codes and standards, as requirements can change over time. Remember that electrical safety is everyone's responsibility. By following the guidelines and requirements outlined in this discussion, you can help to ensure that electrical systems are installed safely and correctly.